Hi, and welcome to today's lesson 4.7 and 4.8. We're going to combine two lessons and actually combine a little bit of stuff that we learned in class for 4.6 as well today. Our objectives are all 5 of those in the green box up top. So we're going to figure out all of those things in sequence today. In 4.6, we talked about graphing linear equations using a table of values. Basically, we can graph an equation that we have here by taking a random sampling of x values. Okay, so I just picked those off the top of my head, -2, -1, 0, 1, and 2, for a few reasons. Some of them are negative, some of them are positive. I've got 0 in there, and they kind of follow a nice pattern, right? So I picked all of those x values. And we take those x values and we substitute them into the equation. So I have an x value here, and I substitute it in for x right there, and I do some calculations, and it spits out a y value. Right, so x is a little bit of like an input, and y is the output. Okay, so basically, we can fill in the rest of this table of values by inputting x. Right, so -1 goes in for x there, and we have 3 times -1, which is -3, plus 1, which is -2. 0 goes in here. 3 times 0 is 0, plus 1 is +1. 1 times 3 is 3. 3 plus 1 is 4. And 2 goes in here. 2 times 3 is 6, plus 1 is 7. So that takes care of filling in the rest of the table of values. I hope we all followed that in class today. Graphing the ordered pairs is just as simple as sort of looking at this table of value and saying that these are ordered pairs. We've got an x value and we've got a y value. We could graph those ordered pairs, right? So we talked about this. -2 and -5 shows up right here. -1 and -2 shows up right here. 0 and +1 shows up right here. 1 and 4 shows up right here. 2 and 7 shows up right here. And you can actually see, it doesn't take much of a rocket scientist to figure this out, all of those points are in a nice straight line. Okay, so you can take a ruler, you can draw a line, okay, and make sure it touches all those points, goes through all of them. Also, I'm going to do something interesting here that I harped on about the class. You want to make sure that there are arrows on both ends of that line, because again, I could have chosen 3 for x. I could have chosen 5, 15, 16. The line goes off in both of those directions. That's why we use arrows. Okay? So we've graphed the ordered pairs, and we've actually even connected the dots to create a line. Now, to determine the slope, we could do 2 things. Obviously, I could I could take these 2 ordered pairs here and do y2 minus 1, y1 divided by x2 minus x1. That's a bit lengthy. I've already graphed it. I spent the time graphing it. So let's just determine the slope by looking at the rise over the run. The rise is 3, and the run is 1, which means that lowercase m for slope is 3 over 1, right? In other words, it's the whole number 3. Fair enough? So that takes care of determining the slope. Determining the first differences. So this is a bit of a new concept that we talked about in class today. We talked about the first differences, explaining the change in y. So the differences between these y values. So we ask ourselves, what's the difference between -5 and -2? It actually is +3. Add 3 to -5 in order to get the next number, which is -2. What's interesting is that we're adding 3 in all of these cases. That's what makes it linear. That's what makes it a line. Okay? And there's also another interesting happy coincidence here, right? We determine the first differences. You'll notice, I hope, that the first differences has something to do with the slope. Now, I'm not going to say that they are the same all the time. They happen to be the same because these first differences actually represent the change in y. They only represent delta y. They don't represent the slope, but they represent part of the slope. You'll remember that the slope also equals delta y over delta x, right? So it represents 3 over, well, what? What is delta x? We'll take a look here. The change in x, because I chose some nice x numbers, is actually just +1 each time. So delta x is actually going to be +1. So 3 over 1 is the same thing as just 3. Okay, so I don't want you to get that misconception. The first differences are the first differences, and the slope is the slope. They're both related, but not the same, unfortunately, okay? So again, we notice that the first differences in the slope are related, but are not necessarily the same. So, knowing what we know now, though, we can actually graph this relation without a table of values. So let's take a quick look back at this equation and ask ourselves, well, where else did we see this magic number 3, the slope of 3? Well, I don't know about you, but there seems to be a 3 right there, okay? So there's a 3 right there, and I'll actually give you the hint that that number in front of x is the slope, okay? And so what we know basically on the next slide is that that number in front of x, what we call the coefficient of x, is going to be the slope. In this graph's case, it's -2. Okay? We also notice something also very interesting about this special point right here. This special point right here is the point where slope doesn't count. If you think about it, that was the easiest thing in my table of values to count, because I took 3 and I multiplied it by 0. That eliminated the slope, right? 3 times 0 is 0. That just left us with that number 1. If you look at our graph, that point is actually kind of an easy to determine point. It's what we call the y-intercept, okay? That y-intercept, okay, is the point at which the line crosses the y-axis. So what's kind of neat is that just basically looking at this equation, we can pull these two pieces of information from it, right? I know that the y-intercept is actually at 4. So this is the y-axis, right? Positive 4 on the y-axis is right here. I know that that green dot that I just sketched is for sure on this equation, is for sure part of this line. I also know a few other interesting things about it. I know the slope. I know that the slope is -2. I also know that the slope represents rise over run. Now, an interesting thing is that that -2 is not -2 over nothing, it's -2 over 1. Well, the rise is -2 and the run is +1. I'm just going to do that in red so we can see it. -2 over +1. Well, if the rise is down 2, -2, here's a rise of -2. And here's a run of +1. This red point that I've just done is basically another point that's on that particular line. Because if you think about it, right, I know for a fact that the equation goes through this y-intercept, goes through that point. And I know that it must obey a slope of -2 over +1. So I count again down 2 and over 1. Okay? So basically, those 2 points are for sure on a line. Now, of course, you could take out a ruler and connect those 2 dots. That wouldn't be that accurate. So let's continue counting down 2 and over 1. Oh, there's another point right there. Let's continue counting down 2 and over 1. There's another point right there. And you can keep doing this in the same fashion and getting these points that create this nice straight line. You can do it in the opposite direction as well, just recognizing that that point represents up 2 and left 1, so 2 over -1, which is the same thing. Okay, so we plot those points, take out a ruler, draw our line, make sure that the line has arrows on both ends, and away we go. So knowing what we know now, we can graph a relation without a table of values. If you want to check your answer, of course, you could take out a table of values. Okay? So if you wanted to, you can take out a table of values and just check. Well, -2. Let's substitute -2 into this equation. Right? So -2 times -2 plus 4. -2 times -2 is +4. 4 plus 4 is 8. There should be an ordered pair of -2, 8. We'll take a look. There's -2. Oh, there's that point. Okay. So again, obviously, drawing a relation as a graph using a table of values works, but it takes a very long time. Just looking at that equation, we could graph it because we've got 2 very key pieces of information: a y-intercept and a slope. Okay, and that's today's video basically. So tomorrow we'll continue investigating this concept and go a little bit farther with it.